Hey, welcome back everybody to lesson 33 of the Dead Earth game development series. In the last lesson, we set up Jill's ragdoll rig, but we didn't actually write any code that was going to show us how we can turn that ragdoll on and off at runtime. That's what we're going to do in this lesson. So the first thing we're going to need is we're going to need our FPS character some way of shooting at Zombie Jill. Now this isn't going to be the final weapon code, because the final weapon code is going to be very tightly coupled to our inventory system, what weapons we've currently got loaded up the mounts, what damage and blast radius those weapons have. And furthermore, it's actually the animation system itself, the system that will be animating the arms, that is going to tell our code via callback functions when a shot is actually fired. Because remember, when you press the mouse button to fire a shot, that doesn't necessarily mean the shot is going to happen right away. What that will do is tell the animator that is working the first person arms to play the fire animation for that weapon, and then on that animation clip we will have an animation curve and an animation state behavior that will call back into our character manager and say, hey, now is the time that the shot is to be fired, and our function will then cast a ray into the scene and see if we've hit any of the body parts of a zombie. Now obviously many of those parts we don't have yet. We don't have the FPS arms in yet. We don't have the inventory system in yet. So what we're going to do for now is start off quite simple and create some pretty simple objects and some pretty simple UI behavior that we can flesh out later on when we have things such as the inventory system, we have things such as different weapons, and we have things such as our FPS animated arms rig. So the first thing that we're going to need is we're going to need a crosshair in the center of the screen so that when we press the mouse button we can see what we are aiming at. Then in our character manager we're going to create some code that's going to cast a ray through the center of the screen and detect whether that ray intersects any body parts of a zombie. Then that code, if it detects that a collision has happened, will then call that zombie state machine's take damage function, which for now will simply ragdoll the zombie. Over the coming lessons we're going to really flesh out the zombie damage system so that every zombie doesn't simply ragdoll when it's hit by a player's bullet. For now though, that's what we'll do. Eventually we will have a much more complicated damage system where the zombie will only ragdoll if it's been dealt a fatal blow. In the case where it hasn't been dealt a fatal blow, we will play a pre-canned animation that shows the zombie reacting to the hit, perhaps lurching forward or stepping backward. Furthermore, we're also going to develop a system where even if the zombie does ragdoll, but it's not dead, we can reanimate it back up onto its feet. But for now, we're going to start off simple, and that take damage function that we're going to implement in our state machine is simply going to ragdoll the zombie. And that will allow us to see how in code we turn our zombies from animated entities into ragdoll physics objects. Okay, so the first thing I'm going to do is create a very simple HUD. This is just going to have for now a crosshair at the center of the screen, but later on we're going to flesh this out into the actual HUD that is used in the game with many more graphical embellishments. So I'm going to go to the game object menu, I'm going to go to the UI submenu, and I'm going to choose to create a text object. Now all UI elements, such as text objects, need to live under a canvas object. Because I just added the text object to the scene, Unity has automatically added the parent canvas object for me. And that's good because it contains all of the default settings that I want. This is going to be a screen space canvas, it's going to have a constant pixel size, and we don't really have to worry about the graphic raycaster script. We're not really going to be doing any raycasting in that sense. We're going to be doing raycasting ourselves. That raycasting is for when you're using the UI system to detect when buttons or other UI elements have been pressed. Unity has also added the event system game object to our scene. We need one of these in the scene whenever we are using the Unity UI, so it's done that for us automatically. We don't have to worry about it. Okay, so if I go back to the scene view, double click on my text, you can see that the UIs in the scene view look really weird. So that they have sufficient resolution, they're actually made really big in world space units. So that square there is the square of our canvas on the screen. So at the moment you can see our text is right down in the bottom of the screen. We want it in the center. So the first thing I'm going to do is, with my text object selected, is I'm going to set the alignment of the text to center, both horizontally and vertically. And then what I'm going to do is center its position. Now when you have a screen space canvas, as we do here, the origin of the UI coordinate system is at the center of the screen. So if I simply set position X to 0, and position Y to 0, hey, we now have our text element right in the center of the screen. Let's call up the game view now so we can see it. Well, it's text and it's very small. Let me make it white so it shows up a little bit more. Let's now change the text. We don't want it to say new text, so I'm going to use the plus or addition symbol for that. I'm going to boost the font size of that up a bit from 14 to, I don't know, about... You can see as I go up too big, it disappears, and that's because the text element itself is being clipped to the bounds of the text area. If we want to increase the size of the text area, we just go up to the top and we can increase the width and we can increase the height, and we should see, there you go, our crosshair showing up again. So let's full screen that and see what it looks like. I think that looks perfect. Let me just press play. Hey, there you go. So now we can come, we can see where we're shooting, and we can go bash and shoot us straight in the head. I'm going to minimize the game window now, and I'm going to rename that canvas game object, and I'm going to call it player HUD, because believe it or not, this really simple lame HUD will eventually become the real HUD of our game, and we're going to add a lot of other elements to it. So what we're going to do now is we're going to open up Jill's AI state machine, and we're going to add some members that will allow us to traverse a hierarchy at startup and grab a reference and store them in a list to all of Jill's AI body parts. We do this so that when she's hit and her take damage function is called, that function will have access very easily to all of the AI body parts, so it can simply visit those rigid bodies and change their kinematic status from non-kinematic to kinematic. That take damage function that we're going to implement in a moment will also take care of a few other things, such as disabling the animator and the nav mesh agent, so that our ragdoll zombie doesn't still try to navigate around the level. Okay, so I'm going to drill down into my Dead Earth folder, into my scripts folder, and into my AI folder, and I'm going to open up my AI state machine script in MonoDevelop. So here I am in MonoDevelop and in my AI state machine script, and the first thing I'm going to add right at the top of my serialized protected variables is I'm going to add a new serialized field that is going to be of type transform, which I'm going to call root bone. This will allow us to store a reference to the root bone of our hierarchy, which in the case of Zombie Jill is a hip bone. And that's going to be very beneficial, because one of the things that we're going to need to do in this lesson in the start function of Jill is we're going to need to traverse a skeletal hierarchy and find all of those rigid bodies that are on the AI body part layer so that we can compile them into a list. So the root bone is where we start our search through the hierarchy. So I'm going to go back to the editor and I'm going to make that connection now so I don't forget. So I'm going to select Jill's AI entity game object, which of course is the game object with the AI state machine on it. And let me see, I didn't save it off, did I? Let me save it off. There you go. And now right at the top, we have a little slot there asking for the root bone. So I'm just going to drag Jill's hips over. I think actually I'm going to move that root bone down so it's underneath the current state type. I like the current state type to be at the top of the inspector. So let me just cut that out and stick it underneath where the current state type is serialized. Let me just save that off, go back and check. That looks a bit better. Yes, I like having it underneath the drop down. I like the drop down to be like the first thing in the list. Not necessary, just something I like to do. Okay, so what we'll do next is under our protected variables, we will create another protected variables. Obviously, I make these all protected fields, guys, so that if we derive anything from AI State Machine, it also has access to them without us having to have a load of member functions in the base class that have to be called. And this is going to be of type list, and it's going to store rigid bodies, folks. And I'm going to call this list underscore body parts, like so. And we'll set this to a new list of type rigid body, like so. And then in our start function, we can start to traverse the hierarchy, find those rigid bodies, and store them in this list. And next up, I had a protected integer, and I call this AI body part layer. And we're going to use this to cache what the index is of the AI body part layer in the start function also. So let's go down into the start function and do that now. Actually, I'll put that in the awake function where we cache all of the components. I'll put a comment in there saying get body part layer, and then I will say AI body part layer equals, and then we use the layer mask class's name to layer function. Just trying to remember what I called it now. What is that? What is that layer called? It's called, yeah, just AI body part. So I'll put a string in a call to that function saying AI body part, like so. And then when we're searching through the rigid bodies in a moment, we'll just be able to check if the layer index is equal to AI body part layer. And then we know we found a valid body part to store in our list. Okay, so what we'll do at the bottom of the awake function, I think I'm going to do this all in the awake function, not the start function, is we will first of all ask Unity to give us all of the rigid bodies that are under our root bone, and then we can sort through them and find out which ones are on the AI body part layer. So I'll create a local variable of type rigid body array. I'll call this bodies and we'll say rootbone.getComponent. Actually, I want to say get components in children, don't I? I want all of the components that are rigid bodies that are anywhere in the hierarchy of bones underneath the root bone. And the component we're looking for is of type rigid body, obviously. And what we should probably do is wrap all of this code in a conditional that just checks we do have a valid root bone, obviously. So root bone doesn't equal null, then fetch all of the bodies, and then we'll iterate through all of those rigid bodies, process each one, and find the ones that are on the AI body part layer, and then add them to our list. So I'll say for each rigid body part in, what did I call it? Bodies. Then inside the loop, we'll do a conditional. We'll just check that the body part that we're processing isn't null, and we'll also check whether its layer is the AI body part layer. So in order to get the layer of the body part, which is a rigid body, we need to get its game object. So we'll say body part dot game object dot layer equals that AI body part layer integer that we've already cached above. So if this conditional is true, we have found a valid rigid body part that is going to need to change from a kinematic to a non-kinematic state and back again when we're going from an animated state to a rigid body state. So we'll simply add it to our list in that case. So we called our list body parts dot add, and then we add that body part. And at the end of this code, we now have in our body parts list all of the rigid bodies that need to be toggled between a kinematic and non-kinematic state whenever we are transitioning from an animated entity to a physics-controlled ragdoll. Okay, so that's our awake function taken care of. What I'm going to do now is I'm going to scroll down, I think, to the bottom of the script, and I'm going to add that new take damage function, which is going to be called by our character manager when it detects that ray that is going to be cast through the center of the screen, through our crosshair, has intersected a body part of a zombie. This is what it's going to call to tell the zombie to apply damage, and in this particular lesson, when we haven't got the damage system done yet, to simply ragdoll the zombie. So it's going to be a public function so that our character manager can call it, or any other script can call it too. It's going to have a void return type. Just like our character manager has a take damage function when the player needs to take damage, our zombies have a take damage function too. So what parameters are we going to supply to this function? So the first parameter this function is going to take is going to be a vector3, which I'll call position. This function will eventually need to know the actual position in world space of where the impact has occurred. That's because we're going to apply a force at that position to blow the ragdoll back when we're using high impact weapons such as a shotgun. Therefore, the second parameter is also going to need to be vector3 called force, and obviously the direction encoded in that vector will describe to us the direction at which we wish to apply the force. And the magnitude of the vector will describe the force we wish to apply. If we shoot a zombie with a shotgun and we shoot it in, let's say, the left shoulder, we know the position where it is, the left shoulder, and we also know the force and the direction that we're shooting from. We can blow the whole ragdoll back in that direction. Very, very cool. But that's all just for kind of graphical effect. The next parameter is an integer called damage, and that's going to describe how much damage we actually wish to do to the zombie, how much we wish to detract from its health, so to speak. Now, when we create the damage system, it's actually going to be a number that describes whether we wish to take a certain amount of damage off of the lower body or of the upper body. But for now, just think of this as some number that we decrement from health, so that when the health reaches 0, the zombie's dead. But we're not going to be using any of this in this lesson. We're just putting it in there for the future lessons when we create this damage system. The next thing this function is going to be passed is the rigid body that has actually been hit. So we'll just call this body part. And as the next parameter, we're also going to pass in a reference to the character manager. Now, the character manager is the script that's actually going to be calling this function. So what we're saying to the zombie is, not only have you been hit, we're letting you know which player has hit you. Now, we talked about this a few lessons ago. Although we're only a single player game, we may decide to expand it in the future to become a multiplayer game. So we could have several character managers in the scene, and this is just our way of letting the damage system know which player has hit us. Once again, probably not going to be used in this lesson, and I'll call this local variable character manager. And finally, I'm going to add another parameter, which is an integer, which is called hit direction. I'm going to set this to 0. And for now, I literally want you to forget what this is, okay? Forget it exists. It's going to be used much further down the line when communicating with Jill's animator to play things such as hit animations. And you'll see that we're going to have different layers that can be invoked when Zombie Jill gets hit, but doesn't want to ragdoll, so that we can have a kind of stumble backwards or stumble left or right. And the hit direction is going to be useful then. But for now, just forget about it. We're not going to use it, and we'll set it as a default to 0. Okay, so for now, in here, we will simply put a debug log that says ouch, just so that we can tell when this function is being called. Now what I'm going to do now is I'm going to leave this code for the moment, and I'm going to jump back over into our character manager, and I'm going to add the code that's actually going to perform that raycast, detect when we have shot a body part of a zombie. We'll find out which zombie the body part belongs to, and we'll then call this function, passing in the position and the force and the damage and the actual body part that was hit, as well as a reference to itself, and we should see ouch come up on the screen. Once we've done that and we know that our firing system is working correctly, we'll then come back in and we will delete this ouch debug log, and we'll replace it with the code that actually ragdolls Jill. So let's save off what we've done, go back to the editor and just check we haven't got any errors. No, we haven't. Unexpected. And now what I'm going to do is I'm going to step up from my scripts/AI folder, and I'm going to step down into my FPS controller folder, and I'm going to open up the character manager in MonoDevelop. Okay, so here I am in the character manager script, and I'm going to add an update function that Unity is going to call every frame, and it's in that function that I am going to use the input class provided to us by Unity to check if the mouse button has been clicked. So this needs to have a void return type, it needs to be called update with a capital U, and no parameters. And then in there we'll use Unity's input class. We'll say if input dot get mouse button down, so that we're only notified when it's clicked, not when it's being held down. And of course we will pass in a value of 0. So on a PC that would be the left mouse button or the first mouse button. And rather than do the code in here, what I'm going to do is I'm going to call another character manager function called do damage. Okay, we've got a take damage function. We're also going to implement a do damage function. And as a single parameter, it's going to take an integer called hit direction. Exactly the same thing we saw when we implemented our AI state machine function a moment ago. We have this hit direction here. And like I said, this doesn't really mean anything at the moment. So for now, what I'll do is I'll create a public function, void return type called do damage, just so we can see it takes an integer called hit direction, which defaults to 0. Now, you're probably wondering what this hit direction is all about. Let me just say this. When we are doing melee attacks and we have, let's say, a crowbar in our hand, some of those animations will be swiping from left to right. Some of those other animations will be swiping from right to left. Now, when that animation is played, we're going to be casting a ray through the crosshair to see what we've hit. But it's going to be the animation itself which is going to tell us whether it was going from left to right or right to left. So I think, if I remember rightly, if it's -1, it means we've played a melee animation that was swiping from right to left, and if it's +1, it means it's going from left to right. And that's important in the zombies take damage function because it describes what part of the body we've hit, and if it's a melee weapon that should apply force, it describes to that function where we should apply force to the zombies ragdoll. But obviously we don't have a set of first-person arms yet, or the ability to play back melee animations. So further down the road, when we add the FPS arms and we construct its animation state machine that has all of that information in it about which melee animation is playing, that's when we're going to be able to really make use of hit direction. Now, the other interesting thing about this is notice that I'm not just going to do the code in the update function. I'm actually going to do the code in this separate function called do damage. Now, the reason I'm doing that at the moment may not be apparent, but will become very, very clear later on. You see, when the mouse button is pressed and detected in the update function, that's not when the shot is actually going to be fired. What will eventually be in this conditional here is a message to the first person arms animator setting some parameter that tells it the attack animation that it needs to play. Now that animation is going to play out, and at some point in the attack animation is the point that the damage should actually be done. I mean, if you think in the case of a shotgun, when you fire the shotgun, you might see in the first part of the animation, the shotgun come up to the shoulder, the finger begin to pull the trigger, and it might only be halfway through that short animation that the gun actually recoils, and it's at that point that we wish to actually cast the ray. So what happens is in our update function, when the mouse button is pressed, we tell the animator to play the attack animation using whatever weapon is currently active, and then it's going to be a state machine behavior in the FPS arms animator that is going to be examining the curve that we've added to that attack animation, will detect when the shot is actually being fired, and will then call the character manager's do damage function. Okay, so this is kind of like a round robin thing, right? We send the message to the animator to say invoke an attack, and then the animator will then call this callback function called do damage to say now actually do the attack. But as we don't have any of that stuff in place yet, we're just going to make our update function call our do damage function directly, and that way everything is in the right place and in the right function for when we add the animated arms later on. So inside our do damage function, we're going to need a few local variables. If this is going to be a ray casting function, we're going to want to create a ray object. So I'm going to create a variable of type ray called ray, and when we do ray casts in Unity, we get the results back as a ray cast hit structure. So we're also going to want to create a ray cast hit structure for storing the results, and I'll just call this hit. And we'll also create a boolean called is something hit, which we'll use just to store a straight boolean result that we're going to get back from any raycast functions that we perform, which will just tell us whether we've hit something or we haven't hit something. Now, something else we're going to need, which we also added to our zombie state machine class, is we're going to need to know the layer of the AI body parts, because that's the layer we're going to perform this raycast against. So we should probably do exactly what we did in the case of our AI state machine. We'll create a private variable here of type integer, and I'll call this the AI body part layer. Set it to -1 by default, and then in the start function, just underneath where we cache the components, I'll say AI body part layer equals, and then we'll use the layer mask class's name to layer function, passing in the name of the layer that we wish the integer index of, which is AI in capitals, body with a capital B, part with a capital P. So now we want to create a ray that goes through the center of the screen so that we can then later on send that ray in to one of the raycast functions that Unity provides us. So that's pretty easy to do. We have access to our camera, don't we? Do we? Yes, we have our camera hooked up in a private variable. That's good news, because we need the camera in order to figure out how we wish the ray to be cast. So this is how we cast a ray through the center of the screen for the given camera. We say ray equals get access to our camera. In fact, I should probably say at the top of this function, if we don't have a camera, then return, because we can't raycast shit without a camera. And I'll use the camera object's screen point to ray function. Where is it? There it is. Screen point to ray. And this function takes a 3D vector. Actually, it really takes a 2D vector. Forget about the Z component, it can just be 0. And the X and Y of this vector that we pass in is simply the X and Y coordinates, or the pixel if you like, that we wish to cast the ray through. So we just need to know what pixel is at the center of our screen. And that's pretty easy to do. We will just create a new vector 3 for this parameter. And as the X parameter, we will use Unity's screen class's width function to divide it by 2. And that will give us the pixel that is horizontally centered in the middle of the screen. So we'll say screen.width divided by 2. And as the Y component of this vector, screen.height divided by 2. And as the Z component, like I said, it's not really used here, so we just pass in 0. So there you go. So just to reiterate, what we're doing here is we're creating a ray, and in order to create a ray that casts through the center pixel of the screen, we need to know what the camera is. So we use the screen point to ray function of that camera, and then we pass in the screen width divided by 2 and the screen height divided by 2, and that will return to us a ray which is now ready to be passed in to a ray casting function. So let's find out whether this ray hits something. So we'll say is something hit, which remember is that boolean local variable that we just created, and then we will use Unity's physics class, and in particular for now we will just use its raycast function. Now I say for now because a ray is essentially infinitely slim, whereas in the actual game we may want to not just cast rays, but we may wish to cast thicker rays, in other words swept spheres, and Unity will allow us to do that. It's pretty useful because it allows us to not have a situation where, let's say for example, you fire registered something like a shotgun that has a blast radius as the sort of shrapnel of the bullet can disperse over distance, we can basically not demand that the player is so accurate with firing the weapon, and we can say essentially we wish the ray to be, I don't know, 10 units thick or something like that. But we'll come back to that later on. For now, we're just going to cast an infinitely thin ray, which means that unless the very center pixel of our crosshair is over a body part collider, it won't cause a hit. So as the parameters to the raycast function, we will pass in our ray as the first parameter. We will pass in as an out parameter our raycast hit structure, which will give us the information about what collider we've actually hit. Now the third parameter is the length of the ray. Now once we have all of our weapons systems implemented and we have various weapons in the game, we're going to set this to the range of the weapon that we're actually using. But we don't have any weapons at the moment, so I'll just do a really big value like, I don't know, 100 meters, or that's not that big, is it? Let's say 1,000 meters. Okay, but we'll come back later and we'll change this to be the range of the current weapon. How it's set at the moment, if the zombie was right in our crosshair but it was more than 1,000 meters away, it wouldn't register a hit. And it's useful obviously being able to set the range because some weapons will have a very limited range, such as melee weapons. We wouldn't want you to be able to swipe a nail bat from left to right and then see a zombie a mile away drop dead. So we're going to be using the range quite a lot to really configure the characteristics of the different weapons that we're going to have available. And as the final parameter, we need to pass in the layer or layers that we wish to perform the raycast against. Now with functions such as this, they don't take the integer index of a layer, they actually take a layer mask. So in order to create a layer mask that just contains our AI body part layer, we just have to say 1 shifted left AI body part layer. So if our AI body part was, let's say, layer 13, we're just creating a mask that has the 13th bit set. Okay, so now we have to check if something has been hit. So we check that is something hit Boolean. Okay, so if we get inside this conditional, we know we've hit something, and the raycast hit information will be given to us that will tell us things such as the rigid body or the collider that we've hit. But with that information, how do we know what zombie that belongs to? And furthermore, we need access to the zombie state machine that is on that zombie so that we can call its take damage function. Well, actually, that's not a problem at all, because you will remember in our game scene manager, we have the ability to register the AI state machines with the game scene manager using any integer key. Currently, we're using it to store the AI state machines based on the instance ID of the zombie's main collider. But we can also store an entry in that dictionary for each of those rigid bodies as well. In other words, as we collect those rigid bodies from the hierarchy at startup, we get their instance ID, and we also register that instance ID with the AI zombie state machine, or the AI state machine, sorry, with the game scene manager. And we'll do that now. We'll go back to the AI state machine class, and I'm in the awake function. So there's the code that we just created, which gets all of the rigid bodies, and for each body part found adds it to our list. But what we can also do here is say game scene manager dot instance, and then call its register AI state machine function, passing in as the first parameter the body part's instance ID, like so, and as the second parameter we pass this because it's the AI state machine we wish to actually store as the value in that dictionary. So now in our character manager, when we hit any body part of a zombie, that body part will have its instance ID stored in that dictionary along with the zombie that it belongs to. So let's save that off. Then if we go back to the character manager, in that is something hit conditional, we can just try and fetch the state machine from the game scene manager that has the instance ID of the rigid body that is stored in the return raycast hit structure. So we do that like so. We will say AI state machine equals game scene manager dot get AI state machine, and of course we pass in the rigid body's instance ID because that's what we registered the body parts using. So we will have the information about what we've hit stored in this raycast hit object called hit. So we will say hit dot rigid body, and then we will pass in its instance ID. And if there is a zombie state machine registered with that rigid body, then we're going to get it back. So assuming we get back a valid state machine, we now know the zombie that we need to talk to. Oh, by the way, guys, I think I might have accidentally paused the video while I was adding this line of code at the top of the function. Notice it says if game scene manager equals null, we also return. I added that as soon as I realized that we needed to talk to the game scene manager, and of course have to cover the possibility where we may not have a valid game scene manager reference, such as if we had used this script in a scene and completely forgot to add a game scene manager to the scene. So now let's just call the state machine's take damage function. So we will say state machine.take damage, and now as the first parameter we need to pass in the position of impact, which fortunately is also something else that the raycast hit structure tells us. So we can say hit.point, like so. For the second parameter, we need to pass a vector that has the direction of the hit encoded along with the force of the hit for graphical purposes if we wish to blow the ragdoll back under the influence of some force. Well, we know the direction of the impact because that's just our ray, right? And then we can scale that by whatever the impact force should be visually. Now, obviously in the real game, once we have all of the weapon system implemented, this is also going to be a property of the weapon. Each weapon will have a blast force, but for now I'll just pass in something like, I don't know, 100. I don't even know what that value should be yet, but that might blow it out into outer space for all I know, but until we test it we won't know. In fact what I will do for now is I will just set it to 1. So I would rather have no force initially, and then in worst case scenario we'll just see it drop to the floor like a bag of bones, which is for some weapons exactly what we want. A pistol shot to the head, for example, shouldn't blow the zombie back. We should just see the zombie kind of stop and then just drop and ragdoll to the floor. As the third parameter is the amount of damage we wish to actually take from the zombie's health. We'll take, I don't know, for this test 10. No, we'll take, oh, it doesn't matter. We'll just take 50 for now. Once again, this is going to be a property of the current weapon that is being used to call this function. So this line of code here where we call the take damage function of the zombie that we've hit, this is the one we're going to have to come back once we have our weapon systems defined, and we're going to have to swap over some of those parameters for the actual values that are stored in the weapon that's currently being used. We also want to pass in the rigid body that's been hit, so that's also in our return hit structure. So we'll pass in that, and as the fourth parameter we have to pass in the character manager, which is simply this, and we'll pass in 0 as the hit direction, because like I said, that's not going to do anything until we have our FPS arms and melee animation system in place. So let me save that off and just see the catalogue of errors I'm going to have when I go back to the editor. There you go, I've got something wrong here. Oh, what am I doing? Obviously what I've done is I've multiplied the ray, which is its own class, by 1. So actually I should probably make that a float anyway, 1.0f. And I need to change ray to ray direction. It's the vector I want. I can multiply a vector with a scalar, but I can't multiply the ray class instance with a scalar because that's just silly. Okay, all of the errors are fixed. Okay, and I'm going to press play now with the console window up so we can see if I shoot Jill and our raycasting code works properly, we should see ouch come up on the screen, right? I need to make sure that my mouse is in. Hey, there you go. Look, I just shot her in the body, I shot her in the head, and you can see all of those ouches coming up on the screen, right? So our raycast is working and our zombie is correctly being identified and its take damage function is correctly being called. So what we need to do now is go back to the AI State Machine class and we need to add the code to the AI State Machine's take damage function that ragdolls Jill when that function is called. So here I am in my AI State Machine class and I'm going to scroll to the very bottom of the script where we have that take damage function that at the moment just outputs ouch. Well, let's get rid of that ouch line to begin with. And also there's something I forgot to do earlier on when I created this function. I really want to make this virtual so that it can be overridden in derived classes. You see, it's actually in the derived classes where most of the work is going to take place. For example, one of the main things the take damage function is going to need to do in the case of a zombie is it's going to take this damage amount and it's going to apply it or subtract it from the zombie's health. But of course, the base class AI State Machine has no concept of health. Health is a property of the AI Zombie State Machine class. So in the base class, we're literally just going to grab the blood particle system from the game scene manager and we're going to emit some particles at the position of impact. And all the rest of the stuff is going to be done in the derived class, which we'll create in a minute in the AI Zombie State Machine class. Okay, so let's first of all check that we've got a game scene manager because we need the game scene manager to get access to the blood particle system. Remember, that's where we stored the reference to our blood particle system, so anything else in the scene that wanted to emit blood particles could access it easy. So we'll say if game scene manager dot instance doesn't equal null, and if game scene manager dot instance dot blood particles doesn't equal null, well then we know we've got a game scene manager reference and we've got a reference to a valid particle system. Then what we'll do is we'll just copy the reference of that blood particle system into a local variable, so we don't have to use that really long name every time we want to access the particle systems. So I'll create particle system local variable called sys, and I'll set that to game scene manager dot instance dot blood particles, like so. Okay, so one of the things that we need to do when we're using the blood particle system is we need to get its transform, and we need to move it to this position, the position of impact, and then tell it to emit some particles. So we will get the transform of the particle system, and we will set its position equal to that position of impact that was passed into the function. The other thing we want to do as well is we just want to make sure that the simulation space is set to world, not local. Now it should always be, because that's how we configured it in the main settings of the particle system, but there may be a time in the future where something is using the blood particle system and it needs to simulate in local space, may have changed that property and not set it back again. So we just want to make sure that simulation space is always set to world. And this is really important, because just remember, if we emit particles from a particle system and the particles are set to be computed in local space, then when we move the particle system to another location to emit particles from there, the particles that we've previously emitted from a different location will move to maintain their position relative to the parent particle system, and we definitely don't want that. So we did that by saying sys dot simulation space, oh no, looks like simulation space has now been made obsolete. Yeah, okay, so I've just upgraded to Unity 5.5, and it looks like in the latest version they've got rid of simulation space, and they've now made this a property, or a sub-property if you like, of another property called main in the particle system. So we'll need to go back and change the couple of other places in the code where we do this as well. Now I could continue to use simulation space here, it still works, it's just been deprecated, which means they intend to get rid of it in a future version of Unity. So let's try and future-proof ourselves here and do this the right way. So I need to fetch a property from the particle system called main, and I think they did this because the particle system is filled with lots of different modules, and you have to get the module to get the settings of that module, but all of the main settings, they weren't part of any module. So I guess they've made the scripting more consistent by making those settings part of a main module now. So I'll create a variable which I'll call settings, and I'll use that to fetch from the particle system its main module, which is called main. You can see it returns a variable of type particle system dot main module. And once I have a reference to the particle system's main module, then via its properties I can access all of those settings that I used to access before without having to jump through these hoops. So I'm after simulation space, there it is, and it's still the same type, so I can set it to simulation space type world, and then finally we'll tell the particle system to emit some particles, and I think we'll emit something like 60 particles, something like that. And I think what I might as well do while I'm here is I might as well copy that code to the clipboard. I'm doing this in Mono Develop, so if you're using Visual Studio or any other IDE, you'll have to do a similar thing. I'm going to search the project for the word simulation space to find all of those other places where I did this thing using the old obsolete method of doing it. So there you can see in my damage trigger I set the simulation space of the particle system, so that needs to be done just like we did it just now. And of course the updated what did I call it? I called it system, didn't I? So it needs to be system.main. The updated scripts will be available obviously from the website that accompanies this lesson. Now if you've been programming from the very beginning in a version of Unity later than 5.5, then you've probably already sorted this out in those previous lessons, but I actually started designing this game on Unity 5.3, so that's why I'm having these problems. Now I've just upgraded. Okay, that one's fine, and I think the only other place we used the blood was in the feeding state. Yes, so let's do that there as well. Oh, good old Unity technologies. I sometimes swear they change things for no goddamn reason whatsoever. Just to make my life difficult, quite honestly. So at the moment, when we press the fire button and the zombie is in a crosshair, we should see a little bit of blood spurt out. It's going to be hard to do at the moment, actually. Actually, I'll maximize it because otherwise the mouse will keep going out into one of the other windows. So let's put the light on. Bosh! Oh yeah, do you see that blood? Bosh! 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 Oh yeah. Okay, let's get away from her. She can't get me through the wire. I don't think I nav meshed her there, did I? Oh yeah, so you can see. Looks pretty lame at the moment, but trust me, it looks okay when we were seeing a sort of ragdoll drop to the ground, or if we're playing a pre-canned animation that sees us step backwards when that blood happens. So that's the only thing we want the base class implementation of the take damage function to do. All of the fancy stuff is going to happen in the AI zombie state machine class. So let's call up that puppy, go down to the bottom of that script, and let's override that take damage function. So actually I'll go back to the AI state machine function and I will copy over the function signature because I don't fancy typing out that parameter list again. I will paste it in there, but of course this time I will change virtual to override. And the first thing we'll do right inside that function is we will call the base class implementation. So we'll say base.takedamage and we'll pass in all of those parameters that we've been passed, like so that when we call into the base function, we get that blood emitting. And then everything we do after that will be specific to just the zombie state machine. Actually, guys, I've just had a thought. It's a terrible idea putting the blood emissions in the base class implementation. You see, AI state machine is supposed to just represent any generic type of AI object. That object could be a robot or a computer system, and those things don't bleed. So actually, I'm totally changed my mind on this. I'm going to get rid of this call to the base class. I'm going to hop back over to my AI state machine class, and I'm going to rip all of that blood emission code out of the base class implementation of take damage, and I'm going to paste the blood emission code into the AI zombie state machine class. Okay, that was a silly idea, and I nearly left myself with an AI state machine class that had to be used only for things that could bleed. Dear me. Okay, so let's go back to the AI zombie state machine class now, and let's go about ragdolling Jill. So the first thing I'm going to do is I'm going to create a Boolean variable that's called should ragdoll. Now at the moment, because we haven't got any pre-canned animations for the zombie when she's hit by a bullet and she isn't supposed to ragdoll, we're just going to set this to true. But later on we're going to come back and this function is going to have two conditionals, one for where she should ragdoll and another where she shouldn't ragdoll and should instead play a pre-canned animation. But like I said, for now we'll just set this should ragdoll boolean to true, and then underneath there we'll put the code in that says if should ragdoll. Okay, which we know at the moment is always going to execute, but later on there'll be another section of code above here that gets executed when she shouldn't ragdoll. Now whether she should ragdoll or not, one of the things we're going to want to do is we're going to want to tell the nav agent to stop walking forward, stop running. We just want it to set the speed to 0. So we'll say nav agent speed equals 0, like so. Like I said, this is true even in the case where we're not going to ragdoll her. We just set the nav agent speed to 0 and then some pre-canned animation will be played that may see her stumbling backwards or whatever, and then that animation will be responsible for setting the speed of the nav agent. But we'll deal with that later. For now, just know that we're stalling the nav agent. Next thing I'm going to do is calculate the magnitude of the force vector that's put in. So I'm going to create a float. I'm going to call this hit strength, and you'll see how this is being used in a minute. And I'm just going to set that to the force vector's magnitude. Okay, so we have a single float which tells us how strong we wish to hit the zombie with this projectile or whatever it is we're attacking the zombie with. In fact, what I'm going to do is I'm going to get rid of that should ragdoll there, and instead underneath hit strength I'm going to say bool should ragdoll equals hit strength is larger than 1.0f. Now, the reason we're doing this is there are times when we wish to ragdoll the zombie, but not when the zombie's necessarily dead. For example, let's imagine we had a gravity gun, right? The gravity gun might do very little damage to Jill. Might have like a damage of like 2 or something like that, but it would actually blow Jill out of the way. So we can't base whether she should ragdoll or not just on what her health is and whether the damage diminishes her health to 0. There will certainly be times we wish to have weapons that will ragdoll her and throw her to the other side of the room, but not necessarily do that much damage. And the way that we do this is the weapons will have this force vector here, right? So each weapon will have a force, and we could have a weapon, let's just say a nail bat, right? A nail bat might do an incredible amount of damage, so it would have a really strong damage property, but would have a force less than 1. So we're saying when we hit her with the nail bat, don't ragdoll her, unless of course the damage is so great and her health so low that the health drops to 0. In which case, we still wouldn't apply a force, she would just be turned into a ragdoll on the spot and would drop to the floor in a pile of bones. So we can think of the hit strength as really being like a property of the weapon. And it's important to understand how for our weapons, its force property and its damage property are decoupled. We can have a weapon that does no damage whatsoever, but applies an incredible force to the zombie, so it ragdolls her and blows her over. Or we could have a weapon that is very deadly, such as a sniper shot to the head, which would have a really high damage, probably 100% damage, but might not have any force at all, in which case she would ragdoll naturally because her health has hit 0. But we wouldn't have any force applied to her that would blow her back. It's like the projectile is going so fast it just passes straight through the head and out the other side. And of course we can have a weapon also that has a strong force and a high damage rate. So what we're doing here is we're saying if the hit strength is larger than 1, then we ragdoll her. Therefore we can easily control for each weapon whether it should ragdoll her by saying if it's a melee weapon and it shouldn't ragdoll her just based on the force of the weapon, then we can set its force to a vector less than 1. Of course, it's worth making the point once again, it doesn't matter what weapon you use, whether it's a hammer or whether it's a shotgun, if the damage caused by that weapon at that time causes her health to drop to 0, she will ragdoll anyway. Oh, actually, when I set nav agent speed to 0, I should probably just check we have a valid nav agent reference, like so. And then inside the if should ragdoll conditional, we'll also check we've got a valid nav agent. And if we have, we'll say nav agent.enabled equals false. We've turned the nav agent off. We'll also get the animator, so we'll check we've got a reference to the animator component, and we'll also disable the animator. Remember, that's a really important point because the animator, otherwise, even when we try and ragdoll her, will actually animate and try and set the positions of each of the bones. So we'll also turn off the animator component. And the next thing we want to turn off is the main collider of Jill as well, because remember she has that big capsule collider around her, but we don't want that to be active when she's ragdolling, which is no longer even remotely synced up to the current position of her body. So we'll say if collider.enabled equals false. So there you go, we've turned off her collider, her main collider that is, we've turned off her animator, and we've turned off her nav agent. What we'll also do is set her in melee range property to false. Now this might be a bit confusing because once she's ragdolled she's dead, right? Well yeah, at the moment that's true, but later on we're going to reanimate zombies that have been blown over on the floor but not necessarily killed. Once again, think of the gravity gun analogy. So when a zombie gets back up again after being ragdolled, we want to kind of remove any state that it had going forward. So if it was in melee range or it was in an attack state, we want to cancel all that so that when she gets upright again, she reassesses the situation. She'll probably go into an alerted state and then try and figure out what to do then. Because just because she was tracking the target before she was ragdolled, if the target was you, there's nothing saying when she gets back up onto her feet, you might be behind her outside her field of view. So we're just going to make sure that when we ragdoll her, we kind of reset all of her states and everything so that when she does get up, we put her in an alerted state and it's like a new zombie being born into the world the first time. Okay, so the next thing we'll do is we'll iterate through that list of rigid bodies that we compiled, which remember contains all of the body parts. So we'll say for each rigid body in, and our list was called rigid bodies, or was it called body parts? It was called body parts. And then inside that loop, assuming that we have a valid rigid body, it's not null or anything like that, we will say body.isKinematic equals false. Remember, when we set up the zombie initially, all of those body part colliders we added as part of Jill's ragdoll were set to be kinematic rigid bodies. Remember, this means they are essentially just colliders that are being dragged around by Jill via the animation of her bones. But they're not being calculated in any way by the physics system and not having forces applied to them. But when we set isKinematic equals false, in other words, when we set them to be non-kinematic, at that point the physics system will start applying gravity and other forces forces to those bones, and that is essentially the process at which Jill becomes the rag doll. Finally, we'll check the value of that hit strength variable to see how strong the force is, and if it is larger than 1, it means this weapon does want to apply some force. So we'll say if hit strength is larger than 1, then we will add that force to the body part that was hit, which remember was also passed into this function. There it is. That's the rigid body that we wish to apply the force to. So we will say, what do I call it, body part? Yeah, we will say body part dot add force, and we pass in that force vector that was passed into the function, which remember is a property of the weapon, and the force mode we want to use is force mode dot impulse. Okay, this isn't supposed to be like a force per second value or anything like that. It's just this is a one-off force vector that we wish to apply right now. Okay, and finally, this isn't going to work at the moment because you'll see what happens if I go and press play now and I shoot Jill. Nothing will happen to her. Look, no, you can see the blood. You can see the blood that I'm shooting, but she's not ragdolling. Now, the reason she's not ragdolling is actually by the design of our system, and that is, we said if the weapon used to hit Jill doesn't have a strong hit strength, if it's not greater than 1, then we won't ragdoll her. Which basically means at the moment, if she isn't ragdolled, nothing happens. She just carries on about her merry way. And if you go back to our character manager, you can see that that is indeed the case. We are just sending in a unit length direction vector of the ray. In other words, we're applying a force of 1 Newton. So let's ramp that up a little bit to, I don't know, so we say 5 Newtons. Not very much, but I just want to make sure that the code gets triggered. So with that compiled, I'm going to press play again, and hopefully now we will see her ragdoll. Bosh! Hey, look at that. And she shouldn't go anywhere. Let me just hang around a minute to make sure she doesn't go anywhere. As you can see, when I shoot her, because she's still a ragdoll comprised of physics objects, the physics does the work for us, and we can see her sort of move as that force hits her. Now, obviously, we can go up now, back to the character manager, and we could put like a really big force in there. Let's try like 50 and see what happens. To be fair, I don't even know if that is a big force. But it's a bigger force than what we had before, right? So let's put the flashlight on and let's see her fly. Bah! You can see she definitely went down stronger. So should we go again this time? I don't know, what should we say? 350? I want to see her fly. I believe she can fly. Okay. Hello, Jill. Oh, I went over the top. There you go. That's what happens if you go a bit too crazy. Okay, let's go like 70. I think what happened there is I hit her so hard, I think the actual joints broke apart. Which we probably do need to check her joints and just make sure. There you go. Just make sure that we haven't got a joint set to break apart. It may be that we have, but I'll let you do that on your own time. Because you don't want to watch me doing that. I'm going to put that down to just about 20, I think, at the moment. Now, of course, the reason why when this was set to 1, she didn't ragdoll and she just went about her merry way, it seems like it's a bug at the moment. But of course, it isn't a bug at the moment. It's just we haven't added any other alternative way yet to that AI zombie state machine function to exhibit the fact that she's been hit. When the weapon that we're attacking her with doesn't have any force applied, what will normally happen is we will trigger a pre-canned animation from what will eventually be a layer in Jill's animator called the hit layer, where we'll have several pre-canned animations that we can call based on where the impact came from. So finally then, let's have the damage that is passed into this function detracted from our health, okay? So we will say health minus equals damage, and then underneath where we calculate the hit strength to see whether we should ragdoll, we'll also modify ragdoll to true if health is smaller or equal to 0. So health smaller or equal to 0, should ragdoll equals true. And then I'm going to go back to the character manager and just check how much health we're subtracting from her. So I'm going to say that our current default weapon, if you like, is going to do 25 units of damage to her health, which basically means I'll have to hit her 4 times before she should then ragdoll, because although the weapon that we're going to use doesn't have a force applied to it, when the health reaches 0, she's going to ragdoll anyway. So let's set the force back to 1 Newton, and I'll try and go, I'll try and let you know when I'm pressing the fire button. It's a bit awkward, right? Okay, so see if this works. So I fired once, I fired twice, I fired thrice, And there you go, I fired a fourth time and then she died. But that wasn't any force that was on the weapon that killed her. It was the fact that her health reached 0. And this is important because when we're doing stuff with melee weapons, they're not going to have a force. So when you're hitting the zombie with a crowbar, that crowbar swing, depending on where it hits her in the body, might be doing, I don't know, like 25% damage. She won't ragdoll until her health reaches 0. But what will happen when we hit her with the crowbar and her health isn't 0 is we will detect what sort of animation should be played on the zombie's hit layer. So you'll see her stumble back, then you'll see her run at you again, then you hit her again and she'll stumble back, and then eventually you'll hit her the final time. She won't stumble back anymore. She's dead. She's just going to ragdoll. So obviously all of these scripts are available for download from the Dead Earth channel's resources section, and I think it's also in a zip file that is under this video as well in the module page. And in the next lesson, I'm trying to think what we'll do. I think we'll probably really flesh out Zombie Jill's damage system. We'll start to set up her animator with that hit layer that I told you about, and start to get those pre-canned animations in place. Okay guys, thanks for listening. I will see you next time. Bye bye now.